Combinations. So the question is, what is the difference between a permutation and a combination? The combination is we don't care about how we're going to arrange them. Right? The actual order is irrelevant. It's just we need to get so many objects. So how does it change it? All right. If I'm going to arrange objects in a line and the order is not important. Now obviously if I use all the objects and the order is not important, how many ways are there that I could do it? Yeah, just one. So really when it comes to combinations, we usually find we're not going to use all the objects. Otherwise the question is quite trivial. So AB would be the same as BA when we talk about combinations. Okay. Let's try and work out a pattern. We've got 5 objects, we're going to arrange 2 of them. If it's a permutation, they're all the different permutations. However, by making this a combination, some of these are now the same. So there are 20 permutations there. But AB is the same as BA. And CA is the same as AC, and DA is the same as AD, and EA is the same as... So we cross out all the ones that have doubled up. We have ended up with 10 combinations. 10 is our 20 divided by 2 factorial. The number of ways those 2 objects could have been arranged. But because we don't care about their arrangements, then I divide by the number of ways they could be arranged, because I'm only interested in one way, and that's if I use those 2. Let's see if that works with arranging 3 of them. Whee! There's all the different permutations for 3 objects. There's 60 of them there. Now using that idea, cross out the repetitions, I should be dividing by the number of ways I could arrange the 3 objects, which is 3 factorial, which is of course 6. I should be left with 10. Let's see what happens. And we are indeed left with 10 objects. So all right. N objects, arrange K of them, not concerned about the order. What we're basically saying is it's the number of permutations divided by the number of ways we could have arranged the object, because we're not concerned with the order. So that becomes n factorial on n minus k factorial on our calculator. That is the combination button, NCK. All right. 6 numbers chosen from 45 numbers. It's a very popular thing. Lots of people do it every week in an attempt to win a lot of money. Right? That's the basis of Lotto. Oz Lotto, you have to go 7 from 45 and so on, but those sort of games. So there's 45 C6 different ways you could do this. 8,145,060. Now, I don't know if you know how much it costs to play Lotto. Anyone know? 40 cents is correct. It's 40 cents. Ain't the reason why people say $2. I think you must play a minimum of 5 games or something like that. So it costs you $2. So if you were to cover every single possibility, it would cost, at 40 cents a game, it would cost you $3,258,024. Okay? But you would cover every possibility and you'd be guaranteed to win. Right? However, it's still a gamble. Because the way Lotto works is if there is someone else who wins, you share the prize. So, okay, if it's one of those jackpots, which is at $10 million, you think, oh yeah, spend $3 million to win $10 million, no brainer. But if someone else does the same thing, then all of a sudden you're only getting $5 million each. Okay, you're still in front. But as soon as a third person comes along and has the same idea, you're only getting $3 million each and you've just made a loss. You see? So the gamble is no longer, will I win? Yes, you will win. But the gamble now is how many people will win. All right, a more typical sort of question. Committees. Committees of 5 obtained from a group, 7 men, 4 women. How many committees are possible? No restrictions whatsoever. So with committees, the order that we pick people doesn't matter. We're just getting a group of people, so it's a combination. 11 people, because there's no restrictions, doesn't matter that they're men and women, and from that we're getting 5. So 11C5, 462 different committees we could put together. What about if we're back in the archaic old days where they used to say, no, the committee's got to be male only, you can't have it, none of those evil women on the committee. Then we're only choosing from 5 people now. No, sorry, 7 people. So straight away, look at the diversity we've cut out by doing that. 21, what were they thinking? Only 21 different committees you could possibly have. So then they got enlightened and they said, all right, the committee can have at least one woman on there. And this is where I'm going to use the complementary idea, because obviously the complement to at least one is none. And we've just worked that out. So I can say, that's 462 minus 21, which leaves me 441 possible committees. I usually find that some people in the room are quite keen on playing cards. The actual topic of probability, its evolution comes from gambling, basically, because people were playing poker and want to know, what's the chance of winning? That's really sort of the evolving point of probability. So what is the number of possible hands? 5 cards, 52 card pack. So 52C5. We have got 2,598,960 possible hands. So 3 of a kind. This is not a bad hand, so they tell me. Don't play poker myself. 3 of a kind. So what do we got to do? The first thing we've got to decide is which number it's going to be. And there's 13 different. Well, when you add in jacks, queens, kings, and what have you, there's 13 different things you get 3 of a kind of. There's 4 of each of those, 1 for each suit. So I want 3. So of those 4 suits, I want to choose 3 of them. Then I'm going to need another 2 cards, which I'm going to choose from 48. Right? And the reason it's 48, even though there's 49 cards left, because if I choose, let's say we were getting 3 aces. We've chosen 3 aces, but in those 49 cards I've got left, there's still another ace. I don't want to pull that one out, because then I don't have 3 of a kind, I would have 4 of a kind. And the question is, how can you get 3 of a kind? So I don't count that extra ace, and that's why it's 48C2, not 49C2. And we come up with 58,656. So the question was probability. So we get 58 over that. 94. Sometimes in probability with things like this, it becomes more convenient. Think of it as a percentage, so then you can compare the different hands. About a 3%, 3.2% chance of getting 3 of a kind. All right, HSC question. A 4-person team is to be chosen at random, 9 women, 7 men. How many ways can this team be chosen? Very similar to our committee's question. 16C4. It's 1,820. What's the probability that the team will consist of 4 women? Well, the number of ways we can get 4 women would be 9C4. So the probability then is 126 over 1820. 9 and 130. 9 and 130. All right, so 10G, we'll do the odds. Ooh, this time I've pulled out 2 of the odd ones not to do, assuming they're numbered the same as my book, of course. But this time order does not matter.